My name is Shu. I'm an engineer from the Mobile Vision team, and then today I would like to talk to you about our API. The Mobile Vision API can basically break down into 4 different components, a common one, and also the 3 specialized detectors. The common API consists of API like utility functions, such as a camera source that allow you to convert a video frame to pictures, as well as our tracking pipeline. And the detectors are the specialized APIs that detect individual items. The face API allow you to detect faces that gives you information like landmark and classification. And then the barcode API detects barcode 1D and 2D, so like QR code, UPC, in any orientations. You can also detect multiple barcodes at the same time. And our newest addition to our family, which is the text API. The text API allow you to detect text in any Latin-based languages. So that's like English, French, and then we'll translate that into text that you can recognize. Before I dive down into details, I want to talk a little bit about the Cloud Vision API and the Mobile Vision API. The Cloud Vision API and Mobile Vision API are 2 different but complementary APIs that are provided by Google. The Cloud Vision API is a RESTful API, so it supports on all platforms. In addition to all the capability of Mobile Vision API, it also provides additional detection functionality, such as landmark, like detection of Eiffel Tower from a picture, as well as like a logo detection. So you can detect like Coca-Cola's and other labels. In comparison, Mobile Vision API is a specialized on-device only capability for Android. There are some advantages to wrong on-device detections, such as it supports offline, and it also supports real-time processing. Additionally, Cloud Vision API is pay-per-use, and then the Mobile Vision API is free. I want to talk a little bit about how to use detectors and pipeline before we dive into examples. So the simplest way to use a detector is just to instantiate a detector. You pump it through the image, and then you get detection items. This is how all the detector works in our API. And then here is how the tracking works with the pipeline. First, you have the camera source that provided by the common API that converts the video streaming into images. And then you take the images through the detector and then get detection results. And then you take the detection result through processor. Processor is like a way to route your detection results into different trackers or custom logic. So once you detect it, it routes it to the correct tracker. So anything in here that's tilted color are provided by our API. You can simply configure them in any way you like. The only thing you really need to implement is the tracker. That's where all your custom logic wants to go when you detect an item. So now you understand how the basic works for detector and the pipeline. I would like to talk a little bit about Face API. So our Face API actually can detect any orientations, and then it can also detect faces with beard, glasses, or even extreme distorted expressions. Additionally, even if it's not fully viewable, it can still detect the faces. And then once the detection is run, detects a face, it provides you information like landmarks, like eyes, nose, mouth positions, as well as classification, which is a stay-out feature, such as smiling or close your eyes. So this operation can be very useful when you want to provide applications such as smart cropping, red eye detection, or always very useful puking rainbow effects. One important thing I want to know is Face API is for detection, not recognition. What that means is it can detect where the face is in a photo, but it does not understand who is in the photos. For example, when I use it with a pipeline video, my face appear in the video. It will assign me a tracking ID, say 1. But once my face move away from the video frame and come back, it will assign me a new tracking ID, which is 2. So it doesn't understand my face is consistent. It just understands the face within the frame. So now we're gonna implement this application together. So this application tracks your faces, landmarks, and then superimpose the really cute googly eye, and then it can detect blinking. So then that's when the yellow blinking is at. Okay, so the face detect, our API is provided by Play Service. You want to making sure you have version 26 or higher. You want to making sure that you depends on the correct version. And then most importantly, you want to add the dependency into your manifest file. So the API tend to require some additional package to be downloaded only for the first time when your application used on a device that use the API. So for face, you just want making sure it's declared, so you will have enough time to download the package before a launched application. So to create a face detector, this is what you do. You use the builder, and then you passing through the options you want. In this particular case, we are using all landmark and all classification. That just means you will return all the landmarks that can detect, as well as all the classification information. So by default, none of the detection for landmark or classification will run. There are multiple different options you can specify, such as a minimal face feature, like how small of a face you want to detect in your image. And then different options has different trade-offs between performances and features, and as well as speed. Before you use it, as I was saying, it requires some additional package to be downloaded, so you always want to check making sure the package is downloaded before you use it. If this function returns false, then no detection result will actually returns. So after that, as we were saying, you pump through the image into the detector to get the faces back. Once you have the face, you can iterate them through and then do custom logic if you want for landmarks. Here is a tracker implementation. Remember, we're saying tracker is the only thing you need to implement, and that's where your custom logic is going. So there are various different states of function you can override to do what you want. In this particular example, we are first overriding the new item. This function is called when a face first detects in images. And then you will call this. And then after that, we're overriding so on this function, you want to create the initial overlay eyes to impose on the image. After that, the onUpdate will continue to be called for the initial face that detects here. So it will continue to deliver the landmark and classification information to you. So in this particular function, you want to update the positions of the eyes, as well as maybe detection blinking. This is where you want to implement the states. So put down the detector and the processor and tracker all together. Like we say in the pipeline, you take camera source, you get images, you pump through the detector. Once you get faces, you go through the processor, and then you implement your own tracker. So here is the tracker we were just talking about. And the detector, as before, you use it as a builder. And then you set the processor on the detector this way. And then here's the camera source. You just set it to associate with the detector. So every time an image frame comes, you automatically call the detector. Detector will detect features, and then you will go through a processor to route through the correct tracker. So that was all great. That's how we detect one single face. How do you do multiple face detection? And this is how. Very similar to before, this portion are all stay the same. The only changes you want to do is the processor. The API provides a lot of different types of processor. So the largest face focusing processor, which is the one we just used, can be simply replaced with the multiprocessor. And then you will instantiate the tracker like so. So here's the changes. We want to implement the multiprocessor. The multiprocessor has an onCreate function. Every time a new detection result is formed, it will call the create. So in this case, you will instantiate a tracker associated with that face. And then this tracker will continuously only receiving information about that specific face that or the detection result you associated with. And then the rest stay the same for the camera source. So now let's talk about text API, which I'm really excited about. So text API, like I said before, that it only currently detects Latin-based languages such as English, French. It can detect text in images as well as, you can see an example here. So this can be very useful, such as providing application like you can look at the ingredients, maybe highlight stuff that might have allergic reactions, such as peanuts, as well as the very common one, which is translation. The text detection here is actually the same one we use for the Orlens, which is the translator application. So additionally, you also understand text structures. So the text recognizes the result comes back. You will actually understand this is a block of text, and then you can iterate it through to get lines information, as well as each individual words. As I said before, the API is provided through the Play service. So you want to make sure you have the correct dependency. And then previously we were saying it's a face, now we're saying it's an OCR dependency. So here's how you use it. Very similar. You will see this throughout the API usage. They're all very similar. If you understand one, you can understand all three of them. So here we use the builder. There's no specialized option you need to pass in. Making sure you check that all the dependent package has been downloaded, and then you pump it through the images. Once you pump through, you get text block. Inside the text block, you can process lines or text and then to overimpose. Right? So this is how we're going to put it together. Instead of the multi-processor or the largest face-focusing processor, we're using an OCR detector processor. And then you pump it through, you custom display your logic. So it's very simple. This one implements the generic interfaces. Here is where you will receive all the detection results. And then here, that's where you can remove or display results or alert the user in any way you would like. What's next? So all the examples you have seen in the talk is available in our samples. Here is the face detection and the mobile vision OCR in our collabs. You can do step-by-step tutorial if you like. We also have an API reference if you like to take a look. And then we are monitored very closely on the Android Vision on the Stack Overflow if you have any questions posed. So I can't do everything by myself. This is my whole giant team that makes this happen. So we have some time, about 10 minutes. I'll take questions from the live audience. If you have a question, if you just raise your hand, we'll have somebody give you a microphone that you can ask questions. And I also have a translator in case you want to ask in Korean. Anybody have questions? Don't be shy. No? Nobody? I'll tell you some. Oh, OK, here. Do we have a microphone? OK, go ahead. Wait, what? Oh, sorry. Here's the microphone.
네, 그 문자 인식 같은 경우에 별다른 옵션이 없었는데 그 만약에 향후에 원하는 폰트라든지 혹은 숫자만 혹은 문자만 이렇게 필터해서 인식을 할 수 있는 기능 같은 것도 제공받을 수 있나요?
So it can understand text in images already. It doesn't require specialized font. It can understand all of them, basically. So there's no specialized need for a font. For filter, you want to use the tracker that we talk about to filter the result as you see feasible. If there is more options we provide in the later on version, you will add it to the option. And then it's a builder, so you can very simple just add the option into the API. Does that make sense?
네.
Okay, great. Yes?
예, 오늘 많은 인사이트를 주신 것 같아서 예, 감사합니다. 이미지나 동영상 검색에서 그 안에 들어있는 텍스트를 찾아가지고요. 그 텍스트를 이미지나 비디오 파일에 태깅 시키는 것도 서비스할 예정입니까? 유튜브나 뭐 구글 포토에서요. 아니면은 그 엔진을 자기 PC에 있는 컨텐츠를 분석할 수도 있을 것 같은데.
Use with your so from the API perspective, when you have images or photo come through, you get text in anywhere in the image, and then it will give you a location exactly where that text is detected in that image. And as far as using it within our other applications, I mean, our library is always based off a lot of our own application, right? So, but I don't know for sure what feature it will appear at. Does that answer your question?
그러면 지금 영화 다운받을 때 이렇게 스크립트 하는 것처럼 이렇게 어떤 비디오 파일에 몇 시, 몇 분, 몇 초에 어떤 타임에 어떤 텍스트가 표현된다 아니면은 어떤 얼굴이 등장된다라는 걸 이렇게 태깅을 시켜놓으면 굉장히 나중에 자기 비디오 파일에서 찾을 때 검색할 때 되게 유리할 것 같은데 뭐 그런 것을 준비 중에 있나요?
I can't say officially yes, but the pipeline actually returns a sequence of the frame. So that might be able to use for the capability you are hoping for.
Thank you very much.
Yeah, of course.
네, 비전 페이스 디텍션에 대해서 여쭤보고 싶은 게 있는데요. 지금 구글 말고도 다른 서드 파티 상용 라이브러리들이 있는데 그거에 비해서 사실 비교해 보면 속도라든가 아니면 그 랜드마크 뽑아내는 그 랜드마크 수가 좀 적거든요. 그래서 향후 이게 어느 정도 그 발전될 예정인지 그런 플랜을 알고 싶습니다.
So currently, we actually allow detection for eyes, nose base, cheek, right, and the 4 points on the mouth, and then left and right ears. We definitely can detect more. I can't say officially when are those going to be available, but it's great feedback. I'll bring it back to my team, and hopefully, we can, open up more landmarks in the future.
Thank you.
Of course. More questions?
네, 몇 시간 전에 이제 클라우드 비전을 설명을 하면서 머신러닝 덱에서 기본적으로 설명을 해주셨는데, 네, 근데 지금 이것도 그 어떻게 보면은 클라우드 비전이랑 거의 원리는 비슷한 것 같거든요. 그럼 지금 이 모바일용 API도 훈련시키는 방식이 거의 유사한 건지 아니면 다른 면은 어떤 점이 다른 건지 그게 궁금합니다.
So the main differences between the Cloud Vision API and the Mobile Vision API is Cloud Vision API requires internet connection all the time. But Mobile Vision API, after the initial downloading the packages, everything is running on device. Nothing is talking through the internet. So imagine you are in a location, say you are in France, and then the internet is really costly. You don't want to use it. In this case, you can use Mobile Vision API to run your detection, to provide capabilities, right, to save money. But I think Mobile Vision and Cloud Vision works hand to hand because Cloud Vision API provides additional capability that just doesn't fit on your device. Mobile Vision is very specialized. such that we currently only support 3 specialized detections. Yeah, is that helpful?
그러면은 머신 그 러닝 과정 자체는 좀 다를 수 있다는 말씀이신 거죠?
I'm not saying the machine learning process is different between the two. The capability provided on the mobile and the cloud for the face, barcode, and also the text is actually the same underneath it. It's that cloud API provides additional capability. So if you think about machine learning, it trains different models. Sometimes the model is too big. It cannot fit on your device. So that's why there also is a complementary portion of it. Questions? We have about 5 minutes. Okay? Okay. Thank you.